Good afternoon, and thank you for joining the ASCS Europe webinar, Beyond Buzzwords, What Can Video Analytics Actually Do? My name is Michiel Gen, Director European Projects at ASCS International, and I'll be your host today. We have a great webinar coming up, but first a few housekeeping items. On your screen, you'll notice a Q&A box to the left of the slides. If you have a question during the presentation, please type it in here and we'll address it during the webinar. Below the Q&A box, you find the resources box. Please note, today's presentation features video footage. Depending on your firewall and/or internet permissions, the video may or may not play. If it does not play, a link to the video can be found in the resources box as well. Should you experience any sound or audio disruption during the webinar, please refresh your browser. At the end of the webinar, an evaluation will pop up, and your feedback helps us to determine future programming, and we appreciate your input. CPE credits for today's webinar will now be updated directly into your user profile within 48 hours after the webinar's conclusion. Self-reporting CPE credits is no longer required for ASCS-sponsored webinars. ASCS International would like to thank Genetec for partnering with us for today's webinar. Genetec develops IP-based security software, hardware, and cloud-based services to enhance security, intelligence, and operations for businesses, communities, and cities. Video analytics helps us to make sense of vast amounts of data by extracting actionable information. This technology has progressed significantly in recent years. Terms like AI, deep learning, and machine learning are now thrown around, with many new companies appearing in the industry. This makes it difficult for end users to filter through all of this. Genetec is particularly well placed to bring you their assessment of the state of video analytics. They have their own line of innovative video analytics solutions. Through their open platform approach, they also work with more than 50 different video analytics providers, including the market leaders from this field. Today's presenters will be Dr. Florian Matusek, Product Group Director of Video Analytics at Genetec, and Jean-Philippe Deby, Head of Buildings and Industrial Market Segment Europe at Genetec. They will introduce themselves. Welcome, Florian and JP. The floor is yours.
Thank you very much. Good morning, good afternoon, good evening, because there are people from a little bit from all over the world which have dialed up on this webinar. So my name is Jean-Philippe Deby. As Michiel explained, I'm responsible for building industrial markets in Europe. And as part of my role, I'm obviously in contact with a lot of different customers, but I'm also trying to keep myself up to date on information that matters, which is topical, I would say, in the market. And looking a little bit at 2020 surveys, a couple of things sticked out. So one was cybersecurity. So that seems to be, let's say, a very big topic. But the next two topics that came out was AI and facial recognition. Speaking with ASIS, we thought that those two topics, would be of interest. I mean, for myself, I've been 15 years in the physical security market. So, obviously, video analytics is not new, as all of us know. It has evolved over the years. I mean, everybody sees the benefits of utilizing video analytics. But on the other end, like I tend to say, and probably I'm not the only one, it still feels, let's say, that video analytics sometimes is more an art than an exact science. So it's very interesting. It's with all of those buzzwords coming out to see, what is going to be the positive impact that it's going to bring to us and to yourselves, to the application that you're going to be deploying. So it's a joy to be with Florian today. So I'll let Florian perhaps introduce a little bit himself. Tell us a little bit more about yourself, Florian, please.
Yeah, sure. Actually, I was kind of surprised yesterday when I thought about the intro that I've been doing this for almost 20 years. Don't feel so old. So my background is technical. I did my master's in computer graphics and digital image processing, so really the field of video analytics at the Technical University in Vienna. I went on afterwards to do my PhD at the University of Oulu in Finland, with a specialty on privacy protection and video surveillance. I did a little stop in between at Skype in Estonia, where I was a video expert there. But in the end, left there because I founded a company with two of my friends for video analytics, and that was now almost 15 years ago, called Kiwi Security. We did lots of things international, very successful. And in the end, Genetec became a shareholder of this company. And today, I'm what we call product group director for video analytics at Genetec. And what that means is that I'm responsible for our own product line for video analytics. So we developed our own, where we believe that it makes sense to have in the platform. But we also have a great ecosystem of tech partners. And I work with these tech partners. So if a new one comes on, I talk to them, try to understand what are their benefits in the end to help them and also our sales team to bring the right partners into the right projects. So I believe I have a pretty good overview over the market from a technical point of view, but also from a company landscape point of view.
Okay, great. Well, as you understood, Florian is the subject matter expert for this presentation, so he'll be doing most of the talking. Now, the way that we've broken down the next 40 minutes is in three parts. So first, we're going to go around a series of buzzwords. I mean, it's the whole title of the presentation. So we'll have Florian explain to us a little bit the background around what those words means, especially in the context of physical security and video surveillance. After that, we picked three utilization of video analytics that we felt, but again from market studies, as being the most utilized in the market today. So the idea is to see, okay, how are those new technologies providing value, hopefully, to those different scenarios. And then the last part is going to be more around architecture. So, how do you deploy, let's say, those new technologies? So, like I mentioned, we basically had to select a number of words, and we felt that these were, let's say, the ones that are, let's say, coming back, more and more in the different articles that you can read. So we're going to talk, first about AI, deep learning, and machine learning. After that, we're going to talk a little bit about, rule-based versus machine learning. We're going to talk about CPU versus GPU, because there's really a big push around that in the market. And then cloud, we're going to be utilizing that a little bit towards the end when we speak, around architecture. So I guess let's start from the top, Florian, sure. with AI.
All right, so AI, as probably most of you know, means artificial intelligence. And what it means is we talk about programs that can sense, reason, and act on their environment. And nowadays, everybody's talking about this, and we feel like it's something new. Actually, this field is kind of old. It was founded in 1956, so back in the 50s, and meant pretty much the same thing. But over time, technologies changed that could achieve that, and of course, it became better and better and better. Actually, there's a saying in this field that says AI is always the thing that you haven't done yet. So as soon as the technology becomes established, it's not part of AI anymore, because that's now standard commodity and technology. So back in the 50s, it might have been automatic chatbots that try to fool you that you're talking to actually a human person when you're writing text. It was super simple. Later, maybe in the 80s or 90s, it was the first push towards automatically reading characters on license plates, so license plate recognition. And nowadays, we talk about, of course, many different things in AI, not only in the video space, but also in banking and insurance, and everything is AI nowadays. So AI is like the field, the overarching field, and that means many different things and encompasses many different technologies. One of them is called machine learning. That's something that came up in the 80s, and is based around the idea of automatically training a system to detect something or do something automatically without specifically programming it to do. For example, for license plate recognition, that might be that you're saying, in order to read a license plate, search in the image for black lines. That might be a number. And then I give you 100 images of the number 6, And this way, you'll automatically learn what a 6 looks like. And the next time you see a license plate with a 6, the system can automatically detect that. And you don't have to program it and say this sequence of pixels is a 6, but you just say search for a black line, and this is how it should look like. So this is machine learning. And a part of machine learning is called deep learning. And deep learning is really the thing that we mostly mean nowadays when we talk about AI. So when you hear out there people saying we utilize AI, what in 95% of the cases, they mean deep learning. And what deep learning means is that's actually pretty much a revolution that happened a few years ago in this field, a part of machine learning, and that said, well, it's kind of nice for character recognition to tell the system detect number 6, but you still have to tell the system it has to look for a black line in order to train it. You cannot do that so well to detect people, for example, because you would have to tell the system detect something that has a circle, which might be a head, and that has 2 arms and 2 legs, for example, and train it. It doesn't really work so well. So deep learning is based around the idea that you don't tell the system anymore what it should look for. You just give it a bunch of data and say, these are all people, this is how a person looks like, and you figure out yourself how a person is actually being described. And that's probably the system figures out much better ways to describe a person than us. So we might say a head and 4 things, and the system learns automatically how to detect that. The big difference to machine learning before is that you don't need 100 pictures to detect something, but you might need 10,000 pictures or 100,000 or 1,000,000 pictures. So big data and lots of information to put into the system.
Okay.
So that's a quick overview of these terms. It's of course much more technical, but the main thing to take away is when we talk about AI nowadays, we really talk about deep learning, which is one technology to detect things.
Okay. So I think that this diagram here is, I'm going to talk a little bit more about, deep learning, where it fits. But then I guess we're now going to more rule-based versus machine learning based approach.
Yeah. So actually, I get sometimes the question, do you have a self-learning system or is it still rule-based? This is actually comparing apples and oranges.
Okay.
Because nowadays, when we talk about deep learning and machine learning, many times it's still rule-based, because even if the system learns automatically how a person looks like, you still have to say, I want to have an alarm when this person enters a certain area. There are some approaches that's not very common, but what you can do with machine learning, for example, is to use motion detection and learn over time automatically what usual motion looks like in order to trigger an event when unusual motion happens. But this works only for very specific use cases, and for most of the cases out there, we still use rules for detecting things and for triggering alarms based on deep learning and machine learning.
Okay.
What I would also like to mention about this slide is that it shows pretty well that machine learning and deep learning are just technologies that enable video analytics. So video analytics itself, this is where the value is created and where certain use cases are being fulfilled that might be detect a person that's climbing over a wall. And you utilize deep learning to detect this person, but it's not, deep learning itself doesn't provide the whole application.
Yeah.
So you might use deep learning in combination with many other things in order to provide the business outcome that you want, which mainly is automating things.
Okay. Yeah, and also like we discussed a little bit before the webinar, I mean, obviously in terms of detecting the information, we're talking about machine learning, deep learning, but I guess before that it was, pixel-based.
Yeah.
Is pixel-based still utilized today, or is it completely out of fashion and basically it's only deep learning that is being utilized, let's say, for analytics?
It's moving away from this because pixel-based has exactly this problem that I mentioned before. If you want to detect a 6, you actually have to say a 6 is this sequence of pixels, so that's very inflexible. But still, it's still around a lot, especially in cameras that don't have AI chips yet.
Okay. But
it's definitely moving in this direction that all the major manufacturers come up with AI cameras that are utilizing deep learning.
Okay. Okay. So the next concept that we're going to go over is CPU versus GPU. I need to jump to the right slide.
Yeah, so GPU and CPU. Nowadays, I get a lot of question, do you support GPUs? Just for the benefit for everybody, GPUs are really the graphics cards in a computer that were mainly pushed in the gaming industry originally, but since this big upcoming of deep learning, GPUs are being used more and more in server architectures as well. But asking if a certain product supports GPUs is not the question you should be asking. The question you should be asking is, what are your hardware requirements in order to achieve this outcome? Because GPUs are, well, they're expensive, and they're also very specialized hardware. They have great benefits, especially for deep learning and machine learning, but CPUs still have, also in video analytics, great use cases, especially if you have distributed architectures. So what we wanted to do here is to give a little bit of a more technical overview about this two different architectures, CPU and GPU, in order to help the audience to basically ask the right questions when they talk to manufacturers. Yeah, so if we go to CPU, that's a lot of details here, but in the end, CPUs are very good for general purpose tasks. You have that's what's being used in computers since the dawn of time, since the 80s, and the performance has been improved more and more and more. In recent years, they haven't become faster, but you added more cores. And due to the architecture of a CPU, it's great to parallelize tasks. So to do many tasks at the same time. And that's also one of the reasons why it's a great general purpose architecture. That's why you use CPUs for in your Windows machines or for many different types of applications. But it's not so great to parallelize single tasks. So you have a very big task that you need to do very fast. CPUs are not so great for that. And that's actually what shallow pipelines also means a little bit. I won't go into the details too much. But if we go to GPUs, that's where GPUs really shine. If you have a very hard task to do, and that is analyzing a video stream or analyzing an image, then in the GPU you can split it up in many subtasks and do that very, very fast. It's also more tolerant to latency. That's really the communication between the memory and the CPU or GPU itself. So we don't have such a speed issue there. But in the end, what I want to give to the audience is that for some applications, it does make sense to use CPUs if you have, for example, small deployments with 1 or 2 cameras and server-based analytics, where you want to have a cheap small machine there to run very also high-performance tasks. You can do that on the CPU, but if you have large deployments with many cameras, many times it makes sense to have a GPU-based system. So if you talk to your manufacturer, I would not ask, do you support GPUs, but I would ask them, do you support CPUs and GPUs? Am I flexible in choosing my hardware, or do I need a specific hardware for your application?
Okay, good. Yeah, just moving through the slide here to work towards the next transition. So here, the whole idea of this first part was really to go over some of the the keywords that are buzzing around. By the way, the presentation will be made available after the webinar, so you have the ability to connect. There will be a link for you to be able to download the presentation. We've also put a couple of links towards source of information that we felt, let's say, were good, perhaps, to re-go over those concepts. I was always told it takes, 5 repetitions, let's say, to relearn. So for me, perhaps 6. So here we're going to move into the second part. And the idea basically is to look at, live application, people utilizing analytics, and to see, how those new technologies are providing benefit to that. So we've selected 3, but before going into those 3, what we would love is to do a small survey with the audience. And the idea is basically for you to tell us if today you're already utilizing video analytics, is which one you are utilizing. So we try to select, I think here, 6 which are sort of, let's say, top of mind. If you are not utilizing analytics today, there's also at the bottom the ability to say that we do not use analytics. And then there's always the other, eventually, if we're missing something here, you can click on others. So we'll just give you, 30 seconds to quickly select the marks, and then we'll have a quick look at the result of the survey before going into the second section. So this is a first trial for us around the survey, so you'll have to bear with us if how the results come out. It'll be a bit of a surprise. So I think that we're at the 30 seconds now, so hopefully everybody has casted their vote. Let's have a look. I need to click on the next slide. Okay, so what's interesting, there's high utilization of license plate recognition, perimeter detection. Okay, so there's more loitering than people counting. That's interesting also. And there's still, let's say, a certain percentage that do not use analytics today. So very interesting. We'll look at those results in a bit more detail, between ourselves. The way that we selected the three utilizations is, again, looking at market studies. We didn't know exactly, let's say, which specific market segment was going to be on this call. So basically, it's sort of a cross-segment study, I would say. And today, what is really, let's say, top of mind is perimeter protection, which, from the survey is what people seem to be utilizing the most. We took face recognition because this is very topical, I would say, coming back to, overall studies about, what people are looking into the future, and then people counting. So, let's start with, sorry.
Yeah, I just wanted to add one thing. Because we looked at a lot of studies, and that's our experience, and those are the mainly utilized ones. But what we also do every year is we look at all the tenders that we answered over the year. And we recently did that for 2019. And for every tender that we answer, we categorize it, what type of technology is being asked there. And if we look at all the tenders that we answered over the whole year, it turns out that over 30% of these tenders required video analytics, which is an interesting statistics by itself because it shows that there's big interest in this field. But we also we categorize video analytics into specific functions, and it turns out it's exactly these three functionalities that are asked the most in bids in this order. So by far, number one is perimeter protection, then face recognition, and then people counting. So that fits directly with also the market studies. We see that directly in the market that this is the case. Okay, so let's go over them. So I will first explain what it is, and then explain a little bit what has changed over the years, because all three of them actually have been around for many years. So if you would have done the same presentation 10 years ago, we might have talked about the same applications, but in a vastly different state from a technology perspective, in a vastly different maturity in the way you can utilize it and deploy these kind of systems. So first up, perimeter protection. So what is perimeter protection? Well, essentially is to protect your perimeter against intruders. That can be, of course, physical barriers, but here we talk about technologies in order to automatically detect that somebody enters a certain area. And the video analytics is one technology that you can utilize, but nowadays many different technologies that are being utilized. So we see there microwave, radar, laser, even
fiber optics.
Fiber optics, yes, many different ones, and also video analytics. And the reason why for video analytics it's being deployed more and more nowadays is because over the last years it became much more accurate and easier to deploy. But this is also a great example that shows that just utilizing deep learning or AI is not the answer to everything. Because if you do person detection for perimeter protection based on deep learning, you need a certain minimum resolution. So it might work very well, but only for a certain distance in the image, because you need a certain minimum resolution. And it turns out that many systems nowadays that are just utilizing AI for person detection, they have a range of maybe 20 meters, 30 meters. And it really depends on the application that you want to use it for, if that makes sense or not. If you want to go further, let's say 80 meters, 100 meters, 120 meters, still other technologies are being utilized, and deep learning might be utilized as verification. So if a person comes nearer, for example, 20 meters, you might verify that this is a person, but for detecting people further away, use a different technology that can use only a few pixels to already detect it. That's not possible with deep learning. Okay. So this is a great application where you see many different kinds of combinations of technologies. And if we look at the applications, we picked 3 of them because these 3 actually show that it makes sense to utilize different types of perimeter protection technologies. If you take a look at airports, with airports you have typically very large perimeters. So it might be that you have kilometers of perimeter that you need to protect, and it's also a high security area. So what you would do there is you combine it with different systems. So you might use radar to have a very long range detection. And for closer range detections, you combine it with video analytics as a verification. So you might even have rules that say if radar triggered and then afterwards video analytics triggered, this is actually a true alarm. So you might combine different technologies there. For correctional facilities, actually video analytics might be a good technology in combination with thermal cameras, where you don't have such a long perimeter. So the perimeter might be 100, 120, 150 meters, where it is important that you have a long range of video analytics, but it's not so long that you need to combine it with things like radar. And finally, corporate buildings, where it might really just be about detecting someone at the entrance. It's completely fine to use video analytics that you might have on your camera already built in, maybe it's even for free, that can very well detect people in the short range, where you might not need a very sophisticated server-based video analytics system.
Okay, so we're going to move to the next slide. I don't know if we need support from our colleagues in Brussels. Okay, I'll click. And I believe I need to click on the next one.
Yeah, I think so.
Go live, yeah.
Yeah, so we wanted to give an example of how perimeter protection looks like in the video analytics space. This is a thermal image camera because this is typically how you reach the furthest detection ranges, where you want to detect someone entering a certain area. And again, I mean, video analytics might be the right choice, but there are many different ways to do perimeter protection. I remember actually one of our first potential customers that I talked with, it was a correctional facility in Germany. He was totally against technology, and he didn't want to look at radar or video analytics or something else. But his technology of choice was using geese, so using animals because they're super aggressive to protect his perimeter. And it actually does work well to a certain degree. The only problem is they can be poisoned. But it really depends always on your use case, what technology is really the best for perimeter protection.
Yeah, I was going to make a bad joke or disappear around Christmas time.
That's true. Actually, they did disappear, but I don't know if it was Christmas time. I'm not sure.
Christmas time, okay. Anyway. So let's move on to face recognition.
So face recognition, what it is, I guess everybody has somehow an idea. It is to automatically identify a person inside of an image. Everybody knows that, or most of the people know that from phones. You can unlock your phone using facial recognition. If you have Google Photos, it will recognize people automatically, or Apple Photos. So this technology has been around also for 10, 15 years, but only a few years ago it really became possible to utilize it. And one way that this is possible is, again, deep learning, specifically for detecting reliably faces in the image, and then also matching these faces. However, it's also important to note that it's still not, it still doesn't work in all applications. And it's not like you can just buy a facial recognition system for video surveillance and just deploy it anywhere, and that's the answer to everything. So again, it's just a very huge step forward, but there is still a way to go, and wanted to show you where it works and where it doesn't work so well.
Yeah, and I think it's interesting the analogy that more the utilization that you're saying, with your iPhone or your Android phone, that you can put your face, the phone recognize you, or even it's able to classify, let's say, the pictures into your phone. So why does it seem to be so complicated, let's say, with video surveillance?
Yeah, exactly. It's a very common comment by end users. If my phone can do it, why can't you do it?
Yeah.
And the reason is that the task of facial recognition is very different depending on what you want to do. If we take, for example, airports, let's imagine you're at the airport and you're searching for a friend that has dark sunglasses, maybe a beard, and you try to find him in the check-in area. It's super complicated for humans, and it's still very complicated for machines as well. And the reason for that is that what you have to do is you have to compare this one image of the person to every other person you see all around this space. And this still doesn't work so well because it's a very complicated task to do. But there's another application at airports that we use almost all the time, and that's the facial recognition at the passport control. That's a much different task. At the first sight, it might look similar, but it's much, much different because what you do there is called verification. So you put your passport there, and there the system doesn't have to compare your face to a million other faces. It has to compare your passport to the face it sees right now. So it's a one-to-one comparison instead of a 1 to a million comparison. So it's vastly easier, and this is the type of system that actually works for many years. And if anybody has traveled in Heathrow, it goes so much faster. It goes through passport control since they have these systems. So this is a great application where it works, while finding people inside of the crowd is still very difficult.
Okay.
And one of the reasons is that we also divide facial recognition into two different types, and that's conscious and unconscious facial recognition. So conscious facial recognition is exactly the example at the passport control, where you want to be recognized. So you go there, you go to the gate, you put your passport in, you want to get through. So you look in the image, you do exactly as they say on the screen, and then you're being detected. And this works very well. Of course, the same goes for access control, for security checks, for any time that a person wants to be recognized, this works well. Same thing on your phone.
Yes.
What doesn't work so well is unconscious facial recognition. And that's where you want to really, on any camera that's out there, want to find a specific person. And people actually don't want to be recognized, or they don't even know that they're supposed to be recognized. So that means they might be covered, they might be behind other people, the camera quality might be bad. So this is a much harder task that doesn't work so well today.
Yeah, and I guess, again, to use the analogy of the telephone, so I personally have an iPhone, so it does, do multiple classification of members of my family, for example. So you see that there is some mistakes being done there, because I see my wife perhaps, in 4 or 5 differently named folders. Also, it's still image, right?
Yeah.
Which I guess is probably less complex than doing that on live image.
Yes. So you do it on still images, so you don't need so much processing power.
Yeah.
Also, the difference with photos is people usually want to look in the camera. And that's exactly conscious facial recognition. So they don't necessarily do it to be recognized, but they are doing it in order to look nice in the picture.
Yeah.
That's why it's easier. Actually, I recently read an article about the trial that has been going on in London about facial recognition. Apparently, it didn't go so well. And one of the reasons why it didn't go so well is because it was raining, as it happens in London, and people were wearing umbrellas.
Okay.
So you couldn't see their faces. And that's a perfect example for unconscious facial recognition, where just due to physical limitations, it's very, very hard, because when it rains, people use umbrellas.
Yeah.
So it might be very difficult to use high detection rates. If somebody looks at deploying facial recognition, what I can recommend is first to be very clear about the application.
Mm-hmm.
So what do you want to do? Is it really to identify people at an entrance, or is it finding a terrorist in a large city? And also, there is the NIST organization or agency in the US, that's the National Institute for Standards and Technology, and their task really is to check different technology and test it thoroughly. And they do facial recognition tests on a regular basis. So most big vendors of facial recognition, you can find there and see the accuracy.
Okay.
What they recently found in a recent report was that there is a certain bias, because if you train a system using deep learning, and I mentioned before, you need lots and lots of data, it's always only as good as your data set or the data that you feed it. And if you're talking about facial recognition, it's about what type of persons you feed in there. And unfortunately, this data usually is the type of people where the systems are being developed. that actually might be in Asia, lots of Asian faces, but it might also be in Western society, lots of Caucasian faces.
Yeah.
And that's how a certain bias is built in, and it doesn't recognize so well other people. But at the same time, what the report showed is that the accuracy went up tenfold or more in the recent years. So even though there is a bias, it's a difference of a fault between 0.001 and 0.002%. So really in the last percentage points, there's a bias, but it became much more accurate in recent years.
Okay, so I made a note in any case to add the link also to that report. I mean, so that you can have a look into it. And okay, so we're going to move to the last utilization of many, but of video analytics. So that's people counting.
So yeah, people counting. What it is really you want to count people going into an entrance, but also know how many people are in an area. And again, that's a technology or video analytics that have been around for many years, but haven't been deployed so much because first, accuracy was an issue. Mm-hmm. And second, it was always required to have specific sensors or specific hardware. So even nowadays, what's being utilized a lot are dedicated sensors that you place somewhere and that count people going in and out, and actually do a good job in doing that. But you need to install the specific devices, which means extra cabling, extra warranty, extra costs just in general. And the reason why it's being utilized more and more nowadays is using these new technologies, for example, deep learning. You are more flexible on camera positioning, you're more flexible on reusing existing infrastructure, and have a much wider range of applications for people counting.
Okay.
So you might even reuse your existing cameras. And there are different areas where you use people counting. So traditionally, if you can just go to the next one.
Yeah.
Traditionally, it has been used in train stations, subways, and also retail, of course. But what we see increasingly is that it is used in corporate buildings for what some people call spatial analytics.
Yeah, and occupancy also very important.
Yeah. So it's still a lot about knowing how many people are going into retail shops, to analyze behavior, to calculate conversion rates. But it increasingly becomes also an information source for companies to know how the building is being utilized. Okay. Are meeting rooms being utilized? Is my cafeteria being utilized? I have open spaces where people can choose their working place. Are they using it or are they not using it? So we're seeing a big trend there towards that.
Yeah, I think it's also interesting with restaurants, within companies, to understand, what is the occupancy, let's say at 12 o'clock, versus 12:30. Don't go there and you cannot find, let's say, a place to sit. I mean, you really have many different type of applications that you can utilize for that.
Yeah, so, absolutely. Yeah. And it shows in our data. It's the third biggest asked video analytic that we see in tenders.
Okay.
We actually brought some examples specifically for people counting, where we see what the benefit is of utilizing these new technologies. In this case, deep learning. And I need to explain a little bit the video before, so it's not so confusing there. So what we're seeing is we're seeing a camera that's placed at a train, really an entrance and exit. So we will see people going from up to down, so exiting the train. It's a very low ceiling, so that's very challenging for video analytics to detect.
Okay. And
what we will see in red actually is all the motion that is being detected as movement in the image. And it's a classical example of a pixel-based system you mentioned before. Yeah. So it detects every pixel that has been changed. And doing that, it tries to find where people are and then count how many people cross the line. And this is the number that we see that goes up when people actually cross the line. So if we roll this video, we will see how hard it is for pixel-based systems. I think one more. We have to click on this.
Yes. Let's see.
Yeah. So what you see there is it's still not playing. Is it playing? Mm-hmm. Okay, we assume it's playing. What you're seeing there is that every circle that you see is a detection of a person. And since it searches for pixels that have been changed, these circles are all over the place. And of these 4 people that are going through, it misses most of them when they cross the line. So the count is completely off. And it's just not useful to use these pixel-based systems in such an application with a low ceiling, lots of light, and so on. Yeah, I see it's still playing there. So it's very, very difficult to do that. And this is a place where deep learning-based detection helps us a lot. So changing the whole thing to deep learning, and that's the next video. We use deep learning to detect what is an actual person. So we ignore every kind of motion in the image, but only detect what is a person, what is not a person. And I'm not sure if the video is playing already.
Yeah, I'm not sure either. Benedict, if you can launch the second video, please.
Yeah, so that's the second video. And using these detections, we can much more accurately detect what is a person, what is not a person. And as you can see, the count is pretty accurate for counting how many people are crossing the line. And this is great because suddenly you can do counting at a train station, at a train where it wasn't possible before. And this is one of the reasons why people counting is deployed so much more nowadays. Now that we can have more accurate systems that are easy to deploy, sometimes even on existing infrastructure.
Okay, so basically we can say that AI and deep learning and machine learning is not really buzzwords anymore, but really things that you can truly utilize in your applications. I mean, it's
yes, absolutely. It arrived in reality, I would say. But it's also important to note that we have to look beyond the hype that's happening in the industry. So it's not enough to just say we utilize AI. That's not the answer to everything. It's still about how you choose your analytics, what's your environment, where you deploy them. So there are many factors, as we see here, that you have to consider when you deploy them. What's your resolution of your camera? If you want to use existing cameras, are they good enough to use video analytics? Yeah. What is the lighting environment? Do you utilize it indoor, which might be easier, or outdoor, where you might have many different environments? As we heard about facial recognition, if it's raining and people wear an umbrella, it probably doesn't make any sense. But also, do you have disturbances through lighting? What's the camera position? For people counting, the camera position should be top down still in order to achieve good results. But on the other hand, if you don't want so great results and just a general idea, you can also maybe utilize your existing cameras that are not top down but have a lower accuracy. With facial recognition clothing and accessories, are people wearing glasses? Do you require them to take them off? Do you require people to look at the camera straight? These kind of things. And finally, also crowd density. If you talk about people detection, do you want to detect a specific person inside of a crowd? Do you want to detect a crowd? Do you want to count people where there are many people at the same place? So these are all considerations that you have to take and really evaluate your specific use case, if it makes sense to deploy a certain technology or not.
Yeah. And then also one consideration that we were talking about yesterday that you don't find on this slide, but it's the legal aspects. So certainly with face recognition in Belgium, for example, today it's illegal to utilize that. I mean, unless it's for national security purpose. But that's an element also that starts to come into place. So with GDPR, and you were mentioning what is happening in the UK for the moment with the testing. So the legal aspects is also something that you need to to look into.
Absolutely. And interestingly, also in the US, there's a big trend to limit facial recognition. There are many states that are looking right now to ban it. Sometimes maybe also going too far, because then you cannot use it at all anymore. And it's great technology that has many great use cases. But it's also clear that we have to do it responsibly, and that it is about data protection, and we need to protect the data of people while still using the technology to bring benefit to business use cases.
Yeah. Okay. So this was a little bit, let's say, the second part of this webinar, which was really talking a little bit, okay, what are the impact of those new technologies around utilization, let's say, of video analytics, which has been there, let's say, for quite some time. So I think that the whole people counting exercise really speaks for itself. How deep learning is really bringing incremental value, even from if we look at this last slide. I still believe it's a little bit of an art and perhaps not yet an exact science, but it's definitely bringing, let's say, a lot of value. So now we're entering the last bit of the webinar, and we're going to look a little bit about the architectures, because there, I mean, there's a lot of, I'm not going to say noise, but there's a lot of proposition in the market. So the idea is to start to cover those different. proposition that we have. I think that I have to click one more time. Here we are.
So today we see four basic architectures how to deploy video analytics. And if you're a user of video analytics, before you deploy them, probably you will at one point think about that, how to deploy it. And these are edge-based video analytics, server-based, hybrid models, and cloud. So edge-based, just to explain that, means that you have your video surveillance cameras and you run your video analytics on the camera itself. So the camera analyzes and decides if something is of interest or not, and then sends it basically to the server where you do something else with it. But then you have server-based analytics. And I remember a few years ago, there was always a discussion, server-based versus edge-based. Will server-based go away because the cameras have become more powerful and so on? And definitely we see a trend that more and more analytics are available on cameras, and also for great use cases. But since analytics themselves become more and more powerful, this technology is improving faster than the hardware can evolve from the cameras. So if you want to do advanced stuff and also be independent of the cameras that you have out there, maybe you have existing cameras, you go for server-based. And this is where video analytics run on a central server. And then we have hybrid models. So some manufacturers propose to do some analytics on the camera, send it over to a server, and then do some more analytics on the server. So to distribute basically the load between them. And finally, we have, of course, the cloud, where all the analytics could be done in the cloud itself, which brings some benefits, but also challenges. And in order to give a good overview and also a basis for decision, we created a side-by-side comparison what the advantages and disadvantages are.
Yeah. So with the presentation that we're going to provide for those who would like to receive it, you will see that there, let's say, some additional slide that sort of breaks down, let's say, a little bit the different architecture in a schematic standpoint. But in the interest of time, here we're jumping directly to the conclusion slide, let's say, around the architectures where indeed you can see a little bit, the difference there.
Yeah. So on the top, basically, you have the advantages, and on the bottom, you have the disadvantages of each model. So if you look at the edge and the hybrid model, this is great for distributed systems. So you have no single point of failure because the analytics is done on the camera itself. So it cannot be that your central server fails and the analytics fails. It also saves some bandwidth because you might not want to stream the video all the time, but only send the video if something happens. And it's also cheaper because you don't have to buy so many servers centrally, even though some cameras might be more expensive if you have edge analytics on them. And they also come with a bunch of disadvantages. So you have to configure each analytic per camera, so it's hard to deploy. You can only do not so advanced stuff because the processing power is limited. And also it really depends on the manufacturer that you choose. They have different levels of quality. Well, if you go to server, it's easy to deploy because you're independent of the camera. You can centrally configure your analytics on all the cameras that you have available. You also have a bunch of processing power. So if you want to upgrade and add new functionality in a year or so, you don't have to replace the hardware. You just add another server and add more power, and then it can do more. And also you're independent of the camera, of course. The disadvantage is you have a central point of failure, so it's centralized. You have to stream all the videos there, so it means more bandwidth. However, you might do that anyway for storage. Depends really on your use case. And it's also more expensive because you have to buy server hardware, you have to buy failover, you have extra network components and so on. And finally, the cloud, and the cloud is really also a buzzword nowadays. It has a great advantages of being easier to deploy. So you can just put a camera, for example, there that streams directly to the cloud, and in the cloud you do the analytics and storage and so on, so much easier. You have virtually unlimited processing power. And also it's compatible with many different brands. And also it's really great for applications where you don't need real-time data. So you might send video to the cloud and that's being crunched overnight and then you get the result. So maybe less for perimeter protection, but maybe it's not so bad for a crowd analysis and know how many people, where people are. Yeah, and the disadvantages, of course, again, you have a centralized system, even though it's not locally. You need a bunch of bandwidth to stream everything up. Processing power for analytics is still very expensive in the cloud. Just to give you one idea, you can rent in the cloud in many different cloud providers a GPU that if you buy it on the market for a server, it might cost $6,000. But if you rent it in the cloud, they charge you $2,000 a month to use it.
Yeah.
So after 3 months, it would already be cheaper to buy it on-prem. So doing analytics in the cloud is still very, very expensive.
Yeah, but on the other end, and without doing, let's say, too much publicity here, but I mean, one of the solutions that we have is to redact videos. So again, under GDPR, if a data subject is going to request some information, well, you can provide the information to the individual, but you should be redacting, let's say, all of the faces of the people which are surrounding the person. So there, actually, we utilize the cloud because, yeah, typically organizations are going to be doing that, I don't know, once, twice, 3 times a month. Normally that's the average. So the thing is that here, as we provide that as a service, you are basically utilizing a very small percentage of time, but of a very powerful resource, which is the cloud. And this is where it becomes, very interesting. So it's not owning it, but basically, let's say, utilizing it on a needed basis. But then you get, let's say, all of the power of the cloud, basically.
Absolutely. And we as manufacturer basically split the cost, and then all our customers can split the cost and utilize only a small part of it for their use case. And this is also a great example of a use case where you don't need to have the face redacted in real time, but only on demand. So it's okay if you wait a little bit for the results. And that's a great application for the cloud.
Yeah. So that sort of, let's say, brings to an end the third part of the webinar. I've prepared, let's say, a summary slide. This is a little bit, my conclusion. I mean, obviously, Florian and I had spoken about this a little bit before. I mean, what is my take from this webinar and what is happening in the market is that, yes, there is a lot of new technologies bringing tremendous value, I would say, to the market. I mean, I think that we've been able to demonstrate that over the past, 35 minutes. But what I see also is that, it's basically continuous innovation. And, it's interesting to see, what were the players perhaps, 5 or 6 years ago in the market and who are the players, today.
Yeah. So
it's very dynamic, which sort of brings me, let's say, to, the second conclusion that, especially related to security, perhaps we didn't drill too much on that, but I mean, from conversation with customers, I mean, detection accuracy, for example, is key. I mean, it's operators which are going to be utilizing this technology. So if the technology is not good, the operators are basically going to switch off. Mm-hmm. So, accuracy is going to be very important. We're going to see changes, let's say, over, different type of providers every year. I think that, having an open platform, whatever system you're utilizing, it's important, let's say, that it's open, I would say, to multiple vendors, multiple technologies, so that you can, jump, let's say, from what works good to what works better, let's say, in the future, right?
Let me just add something to that. We see, as you mentioned, so many new players around in this market because mm-hmm. AI is such a new technology that you have many startups out there, actually very well-funded startups that provide video analytics as a new generation. And I always see that I get approximately every 2 weeks, I get a new application for an AI tech partner mm-hmm. Where we evaluate it and so on. And it's really interesting how much innovation is happening there. And there's somehow also a generational change on what kind of providers are offering video analytics nowadays.
Yeah. And then the last point that I sort of, retain, so it's twofold. So first of all, that, again, for security, I mean, one of the recommendations, perhaps we didn't touch, too much in the conversation, but that, during trials, I think is, the step number one that you still need to do. But then I utilize the expression, okay, all roads leads to Rome, but, some are shorter. And this is coming back to some of the points that you were saying around, the fact that, deep learning, today, because it needs to recognize, objects, you need to have, let's say, perhaps a greater number of pixels than, around pixel-based analytics. So this is sort of the trade-off, around the accuracy. Mm-hmm. But then again, there's also, let's say, other technologies like radar that are complementary or potentially might be even better fitted, let's say, in certain situations. So again, this is something that the audience needs to think about is that, okay, we're sort of focus on video analytic here in the conversation, but if we just take perimeter intrusion detection, I mean, there are many different other technologies that are available. It's really trying to find, let's say, the right mix, let's say, that is going to provide you, let's say, the best results.
Absolutely, yeah.
Yeah. So this was the summary of this presentation. We have a second survey to put forward, and basically the idea, and this is perhaps a bit tight with the questionnaire that you're going to receive from ISIS, is has this information been valuable to you? What we tried to do here really was to start with a first layer of foundation. The idea that we have here for the second survey is basically provide you a series of topics which could potentially be a second webinar. So we're going to let you again have 30 seconds, read through the questions or through the different topics. Please let us know if there's a topic that you'd like to drill more into depth. So if this is a level 100 course, would you like to have a level 200 course around one of those topics? So we'll give you another 20 seconds because I'm also conscious of the time that we're arriving on the hour. So we'll give you a few more seconds.
Take a sip.
Take a sip. And also look at Adam regarding Q&A. Is there some questions of interest there? So we have another colleague here in the room. So I'll move to the next one. Okay. So deep learning. Okay. So, well, the good news is that there seems to be, interest for a next topic, and one seems to be, of more interest. So going a bit more in depth into the explanation of deep learning and machine learning. So this is something that we'll discuss with ASIS and see how we can, organize that. So now the idea, I think, is really to, we have another 3 minutes. I'll just do a bit of publicity to let you know, and, hopefully with what is happening in the world today, we're going to be seeing each other in April in Prague, but there I'll be hosting another session, which is basically on the GSAC of the future. And the idea is really to go on the other end of this conversation, because analytics is going to generate, let's say, a lot of new events, new information. So how do you build your security operations center to basically cope with all of the potential data coming in? So I would love to meet you face to face there, and probably we only have time for one question. So Adam, is there one question that you'd like to throw at us that you thought was of greater interest?
Yeah, it's a pretty common question, actually. It's regarding the camera type. So someone from Acer Drones asked if we can also process videos coming from flying cameras, so drone cameras. With traditional computer vision algorithms, it is typically not possible because they rely on the pixel level data, so they need a static background to extract the foreground. With deep learning, it's not really the case, because deep learning, they are searching for other types of features. So deep learning actually made it possible to process also those streams from moving cameras, so dash cams or body cams or flying cams for that matter.
I think this question also highlights very well that there are a bunch of applications out there for video analytics and AI nowadays, and we just picked the 3 most prominent ones.
Yeah.
But there are probably 10 times more interesting applications for different types, for example, for drones.
Yeah, and that could be the topic, or part of the topic, let's say, for next session on deep learning, to show how it's able to go with a new type of sensors or new utilization of sensors.
Yeah.
So I see that we only have 51 seconds left. So I'd like to thank everyone for their attention. We're actually live from Vienna. ASIS is in Brussels. So Michael, do you want to take over the floor, or we close the session now? Any input?
Thank you, JP, and thank you, Florian, for a wonderful presentation.
Okay, so I think that so basically, I think that we're gonna close the session. So again, thank you very much for taking the time to be with us today. And like we said, I mean, we're gonna collect all of the questions given and make them available with the answers, and we look forward to meet you face to face. And yeah, have a great day or a very good evening, depending on where you sit on the earth. Thank you very much.
Thank you.
Thank you, Florian and JP, for a wonderful presentation. Don't miss JP's talk in the innovation track at ASCS Europe 2020 in Prague. We look forward to seeing you there. Thank you to all the attendees for joining our webinar. Once the webinar ends, an evaluation will pop up. The evaluation is brief, so please take a minute to tell us what you thought about today's webinar. ASS values your feedback as we look to schedule future programming. Lastly, the CPE credits for today's webinar will now be updated directly into your user profile within 48 hours after the webinar's conclusion. Self-reporting CPE credit is no longer required for ASS-sponsored webinars. Have a great afternoon. Thank you very much, and you may log off now.